Hi everyone. Notes 1.8 are on scientific notation. And the first thing we need to do is discuss why we're even doing anything in scientific notation. Um, the whole point of scientific notation is to deal with really, really, really large numbers or really, really, really small numbers. So for example, if I wanted to deal with the number 5,700,000,000 right here, writing it in scientific notation is a lot easier. Writing in scientific notation would look like this. And we'll talk in detail why that's the way we would do it. But it's so much easier to write it out like this as opposed to writing it out like this. Okay, so if you look in this box right here, any number can be written in scientific notation by expressing it in two parts. The first part is a coefficient called A, where this right here, what this is saying right here is A has to be between 1 and 10. And it can be equal to 1, but it cannot be equal to 10. And a power of 10, where the exponent is an integer. So it's always going to be written out like this. The coefficient being multiplied by some power of 10. So for example, right here, it says, tell whether each number is written correctly in scientific notation. If it's incorrectly written, state the reason. So our first example says a horse chestnut has a diameter of 2 times 10 to the power of 0 centimeters. So as long as this number is between 1 and 10, which it is, as long as we've got times 10 and it's to some power that is an integer, then this is correctly written in scientific notation. All right, in our next example, same thing. Do we have a coefficient? Yes. Is it between 1 and 10? Absolutely. Is it multiplied by 10 to some power that is an integer? No decimals, no fractions? Definitely. So this is written in scientific notation as well. The approximate wavelength of infrared light is 0.01 times 10 to the power of negative 5 meters. So looking at this coefficient right here, it is not between 1 and 10. It's less than 1. So this is not written in scientific notation. So we'll say no because A, the coefficient is not between 1 and 10. All right, and in our last example right here, a football field excluding zones is 10 times 10 to the power of 1 yards long. So if we take a look at our coefficient right here, our coefficient is 10. And here's where we have to be really careful. A has to be between 1 and 10, but this is telling us right here that it cannot be equal to 10, which means that this is incorrectly written in scientific notation, that 10 is too big. So essentially, whatever number is in front of that decimal place right here can only have one digit. This has two, so it does not work. So A cannot be equal to 10. So I guess right here in this one right here, we said no because the coefficient is not between 1 and 10. We just have to say not including 10 because 10 is not allowed to be included. So now we're asked to write each number in scientific notation. So if you look here, this is 427.7. So we've got 400, a little bit over 400 of something. So what this is saying is we've got about a little bit more than 4 sets of 100. So pretty much what I'm doing is I'm multiplying 100 by 4.277. Now 100 means 10 times 10. So that's going to be 10 to the power of 2. That's what 100 is. And we know it's 100 because there are two zeros in 100, right? So what this is going to say is it's 4.7277 times 10 to the power of 2. Now, the shortcut is to just move this over 2 times, and that's where the exponent of 2 comes from. But I want you to see why we have to move it over 2 times and we get an exponent of 2. It's because we're multiplying by 100, and 100 is 10 to the power of 2. Right, in our next example right here, this one's a tricky one, so pay really close attention. This is the tenths place, this is the hundredths place, this is the thousandths place. So what this is saying is 7 out of 1,000. 1,000, or 7 times 1,000th. Now, just a reminder, when we have a fraction, that means that our exponent is a negative value. So what this is saying here is it's 7 times 10 to the power of, now just a reminder, 1,000 is 10 times 10 times 10. How do I know that? Because there's 3 zeros in 1,000. So this would be 10 to the power of negative 3 because it is 1 over 1,000. Again, same thing. You are totally allowed to just move this over 1, 2, 3 times, but I want you to understand why we do that. And because it's a decimal, it means that we are not multiplying by 1,000, we are dividing by 1,000, so that's why it is a negative exponent. All right, and number 7, we've got 8,000s right here. So this means 8.5621 times 1,000. But 1,000 is 10 to the power of 3. So this is right here, 10 to the power of 3. Again, you are totally allowed to just say, oh, this moved over 3 times, so it has to be 8.5621 times 10 to the power of 3. But again, I want you to understand where this is coming from, okay? And then over here, we can say for question number 8, we can say that this is just moving over 2 times. Remember, we want by the way, the reason why I'm using these numbers is because this 4.277 is between 1 and 10. This 7 is between 1 and 10. This 8.5621 is between 1 and 10. So I'm going to move this over until I get to a number that's between 1 and 10. So I get 6. But since I moved it over 2 times and it is a decimal, it's a smaller number, it is a negative exponent. But again, if you just understand what's going on here, that will help you to know why we're doing what we're doing. So essentially what this is saying is this is in the hundredths place. So 6 out of 100 is what this is equal to right here. And 1/100th means 10 to the power of -2. Again, because we have a fraction and then 100 is 10 times 10. So 1 over 100 is 10, 1 over 10 times 10. Okay, so now write each number in standard form. So here, what this is saying right here is 7.1 times 10 to the power of 3. 10 to the power of 3 means 10 times 10 times 10, or 1,000. So what this is saying is we have around 7,000. But when I multiply 7.1 by 1,000, I get 7,100. Now again, you can just do the shortcut where you move this over 1, 2, 3 times. Why did I do that? Because this is 10 to the power of 3. So every time I multiply by a 10, you're just moving the decimal place over. So I'm doing it 3 times and then fill these in with zeros. So this answer right here would be 7,100. In number 10, we have 8.12 times 10 to the power of -3. So because it's a -3, that means that this is 1 over 10 times 10 times 10. So here I've got 8.12 times this. So what I have here is 8.12 times 1 over 1,000. So right here, this right here would be in the thousandths place. So here I've got tenths place, hundredths place, thousandths place, and then I would just put this 1, 2 to tag along. But again, you can also just say, well, this is 10 to the power of -3, which means I should have a decimal. So I move this over 1, 2, 3 times. Here's my decimal, where my new decimal place is. Fill these in with zeros, and that's how you get 0.0812. Okay? All right, in our next example here, it's 9 times 10 to the power of 4. But 10 to the power of 4 means 10 multiplied by itself 4 times. So this is 10,000. So this is just saying 9 times 10,000. And when I do that, I get 90,000. But just a reminder, every time you multiply by 10, you're just moving your decimal place over. So 9, when I multiply by 110, I move it over once, twice, 3 times, 4 times. I do it 4 times because this is 10 to the power of 4. fill all of these in with zeros, and that's how we get this 90,000. And then in our last example right here, I want to talk about this in a slightly different way. So 2.5 times 10 to the power of negative 2, because it's a negative exponent, it means we're really dividing. So we're dividing by 10 two times. So we would move this over 1, 2 times, because every time I divide by 10, I move the decimal place to the left because the number is going to get smaller. So I do it 2 times. I replace this with a 0. So I end up getting 0.025. Okay, so now the whole point of this right here is not to just change numbers back and forth between scientific notation and standard notation. It's to be able to understand what these numbers mean in scientific notation and then use those numbers in scientific notation. So in question 13, it says identify the greater number in each pair of numbers. So here I've got 5.6 times 10 to the power of 2 and 2.1 times 10 to the power of 3. Well, in this problem right here, we're multiplying some number, I don't really care what it is yet, times 2 tens. And here we're multiplying some number, I don't really care what it is yet here, times 3 tens. But because right here we have more tens being multiplied together than we do here, we can say that this number is the larger number. And the reason why is because 10 to the power of 3 is greater than 10 to the power of 2 that we have right here. All right, so for number 14, same idea. We've got 3.4 times 10 to the power of negative 1, and then we've got 1.1 times 10 to the power of negative 1. This time we have the same exact exponent. So instead, we now can look at our coefficients because here we're dividing by 110 each time. So here we can say that 3.4 is greater than 1.1. So 3.4 times 10 to the power of negative 1 is the larger number. Okay, 15 through 20 we have discussed in class, so we're going to skip those questions. And then right here, let's talk about these questions right here. So rewrite each number so that they are written in scientific notation. So the problem with these numbers is they are not written in scientific notation because these coefficients here are not between 1 and 10. And sometimes when we do our operations in scientific notation, our answers that we get will end up looking like this, and we have to adjust to make sure that these numbers are properly written in scientific notation. So how do we do that? So I'm going to take this, I'm going to break this apart. I'm going to deal with the coefficient that is not allowed because it's not between 1 and 10. And this piece right here, this 10 to the power of 8, I'm going to deal with that separately. So I'm going to rewrite 45.7 in scientific notation. So I need this number to be between 1 and 10. So it would be 4.57. Okay? Times, now since I move this over 1 time, this becomes 10 to the power of 1. So that is the rewriting of this right here. This is 4.57 times 10 to the power of 1. Then I'm just going to copy down this times 10 to the power of 8. So if you remember, when we multiply, we always add our exponents together. So this right here should become 10 to the power of 9 because when we multiply, we add our exponents. And then this right here is 4.57 times 10 to the power of 9. So this is my answer in scientific notation. So I just want to show you how this works. So I'm going to type this number into my calculator. So I'm going to type in 45.7 times 10 to the power of 8, and I get this number right here. It's 4.57 times 10 to the power of 9 because this number is too big for my calculator to write it all out. So it's telling me the answer in scientific notation. These two numbers are equivalent to each other. All right, in our next example, I'm going to do something very similar. I'm going to take this coefficient and I'm going to take this 10 to the power of 5 and I'm going to adjust this coefficient right here so that way it is written in scientific notation properly. So in order to get this number to be between 1 and 10, I have to move this over 2 times. So I get 8.5. Now, because this number was initially a small number, we should have a negative exponent because we're dividing this 8.5 by 10 2 times to get this number right here. And then I'm just going to copy down this times 10 to the power of 5 that we have here. And in this right here, we have the same base, so we can just add our exponents. So I end up getting 8.5. I just copy that down. And this becomes times 10 to the power of 3, because negative 2 plus 5, team negative won the 2 points, team positive won the 5 points, team positive won by 3 points. So negative 2 plus 5 is 3. Let's see if this is really true. I'm going to type in 0.085 times 10 to the power of 5 right here, and I get this 8,500. Then I can type in 8.5 times 10 to the power of 3, and we get the exact same answer, so we know that this is correct. All right, in our next example here, we have 5,821. I want to rewrite that in scientific notation. So our decimal place is right here. Move this over 1, 2, 3. So this is 5.821. I multiplied it by 3 tens to get this 5,821. But I still have this times 10 to the power of negative 7. Now, right here, we have 10 bases of tens and its multiplication, so we can add our exponents. So this becomes 10 to the power of team positive 1, 3 points, team negative 1, 7 points. So team negative won the game by 4 points, and then we can just copy down this 5.821 right here. And this is our answer here. All right, our last example that we have here. So this 0.000353, I need to change this so that this number right here is between 1 and 10. So I'm going to move this over 1, 2, 3, 4 times. If I do that, now this 3.53 is between 1 and 10. However, to get from this number to this number, that means I had to have divided by 10 4 times. And because it's division, it's a negative 4. And then right here, I'm just going to copy down this 10 to the power of negative 4 right here. It is a complete coincidence that these numbers match. It will not always happen here. So when I have 10 to the power of negative 4 times 10 to the power of negative 4, team negative 1, 4 points, team negative 1, another 4 points. So this becomes 10 to the power of negative 8. And then I just copy down this 3.53. So this right here is how this number is written in scientific notation. And that's it for this video. I can fully understand and appreciate that this might be super confusing. Come with questions to class, and we'll have some time to kind of take some of these questions up, get some practice, get these mistakes out of your system. Just be willing to try, and I promise you, you're going to do okay with this stuff. All right, that's it for this video. I'll see you in class. Bye.